The first example, they give you the position vector, and here is a point. Position vector and a point, they ask you to find A is the velocity, the speed, they're telling you the speed is s over t, and the acceleration vector, which is a over t. So r over t is going to be equal t squared I plus tj. And the point is 4, 2. This is a point, it's not a vector, so be careful. So the first thing, I'm going to convert the position vector to, again, it's up to you. You want to convert to the component form or keep it like with the I and j, it's going to be fine. I'm not going to say it's wrong when you're doing the test. So I'm going to say this is t squared and this is t. Now I'm going to start, first of all, find the velocity. So a, which is v over t, is going to be the derivative of the position vector, and it's going to be 2t and 1. Now, b, to find the speed, that's mean it's the length. B, to find the speed, it's mean the length. So s over t is going to be the length for the position vector. The length of the position vector. Sorry, the length of the derivative. The speed is going to be the length of the velocity, which is the derivative, this one. So it's going to be the length of v over t, or it's the same thing, it's the length of the derivative of t. Both is going to be right, which is mean equal. It's going to be the first component squared plus the second one squared. So that means it's going to be, square root of 4t squared plus 1. That's it. You don't have to simplify it or just keep it like this. This is not a vector, it's a length. So that means this is a scalar. C, they ask you to find the acceleration, which is a over t. It's going to be the derivative of the velocity or the second derivative of the position vector. Let's say the second derivative of t, which is this one. So it's going to be 2 and 0. That's mean, here we go. This is the velocity. This is the speed, which is the length, and this is the acceleration. If you check the second part, we're just going to plug in the numbers. Because after that, we have to figure out how it's going to be the graph. And I'm going to show you, it's super easy to figure out the graph. So B, they ask you find V over 2. That means we're going to use the point V over 2, the velocity when t equal 2. This is the second part. So they ask you find V over 2. That means here is V, here is the vector, which is going to be 2 times 2, and here is 1. That means the result is going to be 4 and 1. That's it. They ask you to find the acceleration when t equal 2. Acceleration when t equal 2. So it's going to be, here is the acceleration. T equal 2 is not going to affect anything here on the vector. So it's going to stay the same thing because there is no t variable. So here is the acceleration vector. So that's it for this example. Now we need to figure out how we're going to find which one is going to be the right option. The first thing, let's see, scroll down. Check here. This is, I didn't choose this one as not now, just click. So we have, first of all, to check our point. This is our point, 4, 2. So now I need to check the point 4, 2 before I start a graphing. So the point 4, 2, here is 4 and here is 2. So it could be this one. 4, 2, it could be this one. So this is the point 4, 2. Let's check the other two graphs. The same thing, 4, 2 and 4, 2. So all the graphs, it's right, with the starting point 4, 2. Now we need to check. Here is our velocity, and here is our acceleration. So the velocity, that means from this point, I'm gonna go 4 to the right and 1 up. So let's check. I'm gonna say here is 1 because this is 5. I'm checking this graph. So 1, 2, 3, 4, and then it's going up 1. So here is the velocity. So this is right. This option is right with the velocity. Let's check the second graph. This one. Here is the 4, 2, and the same thing, 1, 2, 3, 4, 1. The same thing. This is also with the velocity, it's right. Let's check this one. Now check the velocity. It's 1, 2. So this is wrong. The velocity here, it's wrong. So I'm gonna cross this graph. Let's check this one. 1, 2. This is wrong. Because the velocity here, we have 4, 1 from the point. We're gonna go 4 to the right, 1 up. Now let's check the acceleration 2, 0. That means at this point, we're just gonna go 2 to the right, and we're not gonna go up and down. That's it, because the y coordinate is 0. So it's gonna be 1, 2. This is right. Let's check this one. The same thing, 1, 2. But what is the difference between these two graphs? This is go up. Oh, the acceleration here, up. Check the graph. And this is with the order, with the second part is decreasing. So now that's the difference between these two graphs, because it's exactly the same thing, but this is increasing, this one increasing, and this one is decreasing. So our right graph is going to be increasing because it's a speed and velocity is supposed to be increased here on this side. So we're gonna choose this one. It's not decreasing. That's mean I'm gonna choose this one. That's it for this example. Where's the check part here? Yeah, that's right. The same thing, you're gonna do it with the second graph, the second example. Now we have circle, which is the same thing. Don't confuse yourself. If it's a circle, I'm gonna do exactly the same steps. So the second one is going to be, now the position vector is r of t equal 4 cosine r of t. This is example 2. R of t equal 4 cosine ti, 4 cosine ti plus 4 sine tj. And the point is 2 square root of 2 and 2 square root of 2. That's been in the first one. So the point, you see the point in the first quadrant. So let's check this one. How we're gonna work on this example. We're gonna do exactly the same thing. The first thing, I'm gonna convert the position vector to component form. So it's gonna be 4 cosine t. T is an angle. I have to write down like this. And 4 sine to the t. So this is the position vector. Now I need to find the velocity. So the velocity with respect to the t is going to be the derivative of r with respect to the t. So the derivative for the first one, for the cosine, is going to be negative sine. That's mean negative 4 sine t. And the derivative for the sine is going to be cosine. So this one is going to be 4 cosine t. This is the velocity. To find the acceleration for this one, we didn't submit the previous example, which is okay. So the acceleration with respect to the t, that's what they ask us to do on the speed. Let's find the speed first. The speed s over t is going to be the length of the velocity with respect to the t, which is going to be the length, that means square root of negative 4 sine to the t squared plus 4 cosine t squared. So this one is going to be equal the square root of, this is 16 sine squared with respect to the t, plus 16 cosine squared with respect to the t. And this one is going to be equal the square root of, I'm going to take the 16 as a common, and the left is sine squared to the t plus cosine square of t. This one is going to be equal 1. Cosine square plus sine square is going to be 1. That means it's going to be the square root of 16, which is equal 4. So the speed is going to be 4. The third one is going to be, the second part is evaluate when the angle is pi over 4. So let's evaluate when the angle is pi over 4. That's mean we need to find the velocity to the pi over 4. So here is the velocity. So it's going to be negative 4 sine pi over 4 and 4 cosine pi over 4. That means it's going to be equal negative 4 sine pi over 4, which is 45. That means the sine is going to be 1 over square root of 2, or you can type it 2 over square root of 2. Or 1 over square root of 2 is going to be the same thing. And 4 cosine is going to be, let's type it as a 2 over square root of 2. Or 1 is going to be the same thing. If you want to simplify it, this one is going to be negative 4 this one is going to be the square root, oh, sorry, negative 2 square root of 2. And this one is going to be 2 square root of 2. That's it for this one. I stopped recording. So you can keep this one 1 over square root of 2 as a sine and cosine, 1 over square root of 2. Now the 4 is 2 times square root of 2 times square root of 2. So I'm going to cancel this one with the root. The left is 2 square root of 2 with a negative sign. The same thing with this 4. It's 2 times square root of 2 times square root of 2. Cancel this. So the left is 2 square root of 2. Now the next one is to find, so here is the velocity. To find the acceleration, we're just going to plug in. Oh, we didn't find the acceleration. We didn't find the acceleration here, this one. So I'm going to go back again and find it. The acceleration of t is going to be the derivative of the velocity, or the second derivative of the position vector with respect to the t. So here is the velocity. The derivative for this one is going to be negative. For the sine, it's going to be cosine. So it's going to be -4 cosine with respect to the t. And here is going to be -4 sine with respect to the t. So -4 sine with respect to the t. Now, this is the acceleration. To find the acceleration to the pi/4 is going to be -4 cosine with respect to pi/4 and -4 sine pi/4. Now this one is going to be -4 times 1/√2, and this is -4 times 1/√2. Simplify these, so it's going to be -2 √2, and here's -2 √2. So that's the acceleration with respect to t. Let's plug in these. So the velocity is going to be -4. Here is the vector, -4, -4 sine to t, and outside we have to close the parentheses, and the plus, or put the comma, 4 cosine t, 4 cosine t. Close the parentheses. This is the velocity. The speed is going to be 4. And the acceleration, here is the acceleration, which is 4, -4. The acceleration is going to be as a vector, is going to be -4 cosine t, -4 cosine t, close the parentheses, comma, and -4 sine, -4. So that, yeah, -4 sine to the respect to the t. Now, the velocity for pi/4 is going to be -2. We have to write down as a vector. So -2 square root of an operation, square root of 2, comma, the acceleration is going to be 2 square root of 2. The operation, square root of 2. And the acceleration is going to be just exactly the same one. This one, I can't copy paste. I thought I can. So it's going to be -2 square root of 2. And the other one is going to be negative also 2 square root of 2. That's it. Now we have to find which one is going to be the right graph. Again, so check these 2 points. This is, if you look, it lies here on this side, on this coordinate. And this one is negative on this one, negative, negative. So let's check now. That means the graph is supposed to be, the circle is decreasing like this. Because we have the velocity, one coordinate of the velocity is negative and the acceleration both negative. That means is, so we can choose this one, we can choose this one. Let's go down to the next 2 graphs here and let's check. So here's the point we have, which is -2 2 square root of 2, 2 square root of 2. That means here is these two vectors. Let's check the velocity. The velocity goes to which point? Negative 2 square root of 2 and 2 square root of 2. That's meaning from this point, if I want to go to negative x, it's going to be going to this side. Then I'm going to go up to the y coordinate, 2 points. That's mean, you see the distance between this point and the y coordinate. This is 0, 1, 2, and here is the root, because square root of 2. So now, if I want to graph my velocity, which is negative 2 square root of 2, the x, that means I'm going to go to the left side. I'm going to go to the left, and here's the distance to the left. Then if I want to graph the y, that means I'm going to go up. So I'm going to go up. So the velocity vector is going to be like this one. So they put the acceleration here, which is wrong. So here, the graph is decreasing. And check, I'm going to go 2 points to the left, 2 square root of 2 to the left, because it's negative. Then I'm going to go up 2 point, 2 square root of 2. That means here's the vector of velocity. The same thing with acceleration. Let's check that. It's negative, negative. That means I'm going to go 2 square root of 2 to the left, and then I have to go down to square root of 2. So that means this is the acceleration. This one is going to be the right graph. Let's choose this one. Check. That's it for this one. That's the wrong thing with this one. Let's check that. I put extra comma here, so that's why it's wrong. We're going to do exactly the same thing with the next example. Example 3, exactly the same thing. To question 3, let's do the same thing. So now with the third one, we have the position vector is r of t. R of t equal t squared I tj t squared I plus tj and plus 6 plus 2, not 6, 2 t 3 over 2 k. 3 over 2k, and the time t equal 4. So I'm going to convert the position vector to component form, t squared, t, and 2t, 3 over 2. Now let's keep moving on. Find the velocity, that means the derivative for this one. So it's going to be, this is A, the velocity of Lt is going to be the derivative of r of Lt, and this one is going to be equal 2t and 1, and 3 over 2 times 2, so it's going to be 3. T 3 over 2 minus 1 is going to be 1 over 2. Okay, because we just find the derivative. So this is the velocity, the speed. So this is b. The speed of t is going to be the length for this one, the length of the velocity with respect to the t, and it's going to be 2t squared plus 1 squared plus 3t 1 over 2 squared. So this one is going to be the square root of 4t squared plus 1 plus 9. This one squared, so it's going to be just t. So that's it. This is the length for, or the speed for this position vector. And the c is going to be, well, ask us find the acceleration of t with respect to the t is going to be the second derivative, or the derivative for the velocity. So v prime with respect to the t, which is going to be, here's v prime. We're going to find the second derivative for the position vector is going to be 2, and this one is going to be 0, and this one is going to be 3 over 2 t negative 1 over 2. Now, to find the acceleration, we're just going to simplify this one. So it's going to be 2, 0, not simplified, just write down 3 as over 2 over square root of 2. There is the t. This is t, not 2. So 2 square root of t. So that's the acceleration. Now, b, the second part of this equation, they ask you to find v of 4. So I'm going to find now v to the respect to the 4. So here is the velocity. So it's going to be 2 times 4 and 1 and 3 to the 4 to the half, which is the square root of 4. So it's going to be 8, 1, and 3 times 2, because this is half, so it's going to be 6. So this is the velocity with respect to t equal 4. And the acceleration with respect to the 4 is going to be, we're going to plug in here. So it's going to be 2, 0. Just here is going to be 3 over 2 square root of 4. And this one is going to be equal 2, 0, and 3 over 4. Because square root of 4 is going to be 2. 2 times 2 is going to be 4. That's it for this example. We're just going to plug in the velocity with respect to the t is going to be, here is the vector, and it's going to be 2t, 2t, comma 1, no, t, 2t, comma 1, comma 3. I think you can write down as a square root if you want to type it 3 or to the 1/3. Let's check if we can write down like this. Comma, that's it. And the speed is going to be the square root of 4t squared, 4t squared plus 1 plus 90 plus 90. And the acceleration is going to be 2, comma, oh, where is the vector? 2, comma, 0, comma, we're gonna write down fraction 3 over 2 square root of t, square root of t. And this one is going to be, as a vector, is going to be 8, 6, 1, 8, comma, 6, comma, no, 8, 1, 6, sorry, 8, 1, 6. And this one is going to be, as a vector, is going to be 2, comma, 0, comma, direction, this one, 3/4. 3/4. Let's check this one. Was the wrong thing here. 2t, t3, t. Oh, why I put the 3? It's 2. It's still wrong. 3. Oh, where is the t? Let me delete this one. So 3t to the exponent. I delete everything here. To the exponent. Fraction 1/2. That's it for this one. So let's start with this one, example 4. We have now a of t equal 6i plus 6k, j equals 0. So that means the vector here is going to be 6, 0, and 6. And the initial velocity v of 0 equal 9j. That means 9j, 9j. Let's write down the point first, then we're going to convert it to the vector. A with respect to the t. 9v is going to be 9j. That means as a vector here, it's going to be 0 and j is 9. Then let's check here. The second one is r, the position vector with respect to the 0 equals 0. That means is 0 and 0. This is the initial points for these. Now I'm going to find the velocity. The velocity is going to be with respect to the t, is going to be the integral to the declaration with respect to the t dt. That means I'm going to do the integral for this vector, which is equal 6t, and here is going to be c, and I can't write down 1 because I have to find the c, and this one is going to be 6t. Now I'm going to use this one to find the value of c. So v with respect to the initial point when t equals 0 is going to be equal 6 times 0, and here is the c, and here is going to be 6 times 0. V of t equal 9, so this means this equal 0, 9, and here is equal. We have to add the k because we're working with the 3 dimension, is going to be fine. So this one is 0, c, and 0. Let's add the k. In this case, and the k here is also 0. So let's add the k here. That means c is going to be equal 9. So now the velocity with respect to the t is going to be 6t as a vector, and c is going to be 9, and here is going to be 6t. Now I have the velocity. Next step, I need to find the position vector. So the position vector is going to be the integral of 6t. Let's write down as a point. The integral of the velocity with respect to the t dt, which is mean the integral of this vector 6t and 9 and 6t with respect to the t. dt, I'm doing this in the steps. So r of t is going to be, take the integral for this one, as a vector is going to be 6t squared over 2. So it's going to be 3t squared. And here is going to be 9t. And the last one is going to be 6t squared over 2. It's going to be the same thing, 3t squared. But we need to add the coefficient because we don't want the integral. So we need to add c. This c is different than this one. This is the constant. We have to add it. Then by using the initial r of t, we're going to find this constant. That means r of 0 is going to be 3, 0 squared, and 9, 0, and 3, 0 squared, plus c. Then the position vector, which is the point 0, 0, 0, or the vector, sorry, not the point, equal is going to be 0, and here 0, and this one is also 0, plus c. That means c equals 0. So our position vector with respect to the t is going to be 3t squared and 9t and 3t squared. This is our position vector. The last thing they ask you to find r with the t equal 7. That means it's going to be 3 times 7 squared and 9 times 7 and 3 times 7 squared. That means it's going to be 3 times 49. 3 times 49 is going to be 147. So this one is going to be 3 times 49, yeah, 147. And this one is going to be 63. And this one 147. And t equals 7. This is the position vector for the object or for whatever here they ask us to find. So let's check these. Let's write down as a vector. Question 4. So the v of t, here is v of t is going to be as a vector. Is going to be 60, 60, comma, and it's going to be c, not c. Where is the position vector? Here is the position vector 9, and comma also 60. And r of t, the position vector is going to be, here is the position vector, it's going to be 3t squared, 3t squared, comma, is going to be 90, comma, and it's going to be also 3t squared. 3t squared. And with the 7, another vector is going to be 147, comma, and the other one is 63, comma, 147. Let's check that. And you're going to do exactly the same thing with the next example. But now we have different functions, and we're going to do the opposite thing. So next problem, problem 5, we need the same thing, find the velocity, the position vector, and the position vector with respect to t equal to. So our acceleration vector, so this is number 5, a with t equal e to the ti minus 8k. E to the t with I minus 8k. That means I'm going to write down the vector right away. So A over T is going to be, this one is going to be E to the T, and J is 0, and K is -8. Now let's write down the initial velocity V with respect to the 0 equal as a vector 2I plus 7J, 2I plus 7J plus K. Yes, that means the velocity with respect to the 0 is going to be 2, 7, and 1. Now, the position with respect to the 0 equals 0, so it's going to be 0, 0, 0. So we're going to do exactly the same steps. The first thing, I need to find the velocity with respect to the t, so it's going to be integral for the acceleration with respect to the t dt, which is going to be equal. I'm going to do it right away here. I'm going to find the integral for this one. So it's going to be e to the t. This one is going to be c, and this one is going to be negative 8t. I did the integral right away. So now we're going to use v naught. V with respect to the t equals 0 is going to be e with the t, and here is c, and here is -8 times 0. V with respect to the 0 is going to be this vector. So it's going to be 2, 7, and 1. And equal this one is going to be 1, c, and 0. In fact, let's add this one. The c is outside, which is the same thing. I'm going to keep this one as a 0. So I can find how much is going to be c, because I'm going to move everything here to the other side. Let's keep this one, the c. When I did the integral, keep this one 0 and add the vector c outside. Keep this one 0 and add c, because now c as a z vector, which is like this one, is going to be, it's with the j, so 0, 1, 0, like this. That's why we're going to find the value of c as a vector. So move this one to the other side, this vector to the other side. So as a c vector is going to be 2, 7, 1 minus 1, 0, 0. And this one is going to be, as a c vector, is going to be 2, it's going to be 1, and here's the 7, and here is 1. We're just going to add this one to our velocity vector. That means v over t is going to be equal this one with the first one. Here is, put this one as a 0. So here is the velocity vector. Now our velocity vector plus the vector c, which is, here is the new vector. So it's going to be e to the t plus 1, and it's going to be 7 here, and it's going to be 1 here. So -8 t plus 1. So that's the difference between this example and the previous one. When you find the c as a vector. The next step, we're just going to find the acceleration for this one. So, sorry, the position vector. So I'm going to take the integral for, so the position vector with respect to the t is going to be the integral for the velocity vector dt, which is equal, I'm just going to take the integral for this one. So it's going to be et plus t, and it's going to be 7t, and this one is going to be 8t squared over 2. So it's going to be -4 t squared plus t. And now another vector plus c as a vector. Now we need to find this one. The initial vector, initial position vector r of 0 equals 0. So it's going to be e 0 plus 0 and 7 times 0 and negative 4t squared. So negative 4, 0 squared plus 0. And this one plus c as a vector. So 0, 0, 0 is going to be equal 1 plus 0 and 0. Let's write down 1 plus 0 just a 0. Don't have to do extra steps. And this one 0 plus c. In this case, c is going to be equal negative 1 because you're going to move this one to the other side. So as a c vector is going to be 1, 0, 0. We're going to add this one to the position vector. So our position vector is going to be e to the t plus t and 7t and negative 4t squared plus t. Everything is minus 1. Oh, you're going to add negative 1 because here's the negative 1. It's going to be here with the first function. Because ijk, let's add it here. You don't have to keep it outside. So negative 1. And the second one is going to be 7t. And it's going to be negative 4t squared plus t. That's it. This is the position vector. With respect to which point? With respect to the 2. So I'm just going to say e to the 2 plus 2 minus 1 and 7 times 2. And here is going to be negative 4, 2 squared plus 2. Let's check this one. We can keep it like this. When we plug in e to the 2 plus 1, and here's 14, and this one is going to be 16, negative 16 plus 2, negative 16 plus 2 is going to be negative 14. That's it. Let's check that. The velocity is going to be, I'm going to look where is the velocity here. We're done. Here's the velocity vector. That means here's my velocity vector. And here is the position vector is going to be this one. And here's the final result. So the velocity is going to be as a vector e to the t minus 1, e operation to the t minus or plus 1, and comma. It's going to be the second one is going to be 7, and comma. The third one is going to be negative 8 t plus 1. The position vector is going to be as a vector. Here's the position vector is going to be e to the t and plus t minus 1 plus t minus 1, comma, and 7t and comma, and the last one is going to be negative 4t squared plus t. And with the 2 is going to be also a vector e to the exponent 2 and plus 1, comma, 14, comma, negative 14. Let's check that. So we can move to the next example, which is really important one. There we go. So that's why we assume that there is no air resistance, because the air resistance is going to change the direction, or it's going to change the object if you throw an object. And the gravity, which is 32 feet per second. Why they mention these two twice? I don't know. Determine the maximum height. We need to find the maximum height and the range of a projectile fired at height of 3 feet. So that's why I grabbed this one. Like they throw an object, a projectile fired at 3 feet. So the start height here is a 3. So keep this one in your mind. I'm going to use 4 feet. So it's going to be a different example, because I think you're going to get exactly the same one, the same numbers. Above the ground with initial speed 600, I'm going to use 800. So it's going to be different numbers than here. So I'm going to use, the gravity is 32. I can't change it. The initial velocity, I'm going to do it 800. So when you do these steps, you have to change the numbers. And the theta, I can't change it. This one is the easiest one. So they ask you to find the maximum height. That means here is going to be the maximum height. And the second one, the maximum range. This one is going to be the maximum range for the projectile. So if you check at each point here, we have the location for each point here. We have 2 components, the horizontal one and the vertical component. So we're gonna start with because when the projectile here is going to be a vertical position and horizontal position for each point, even on the start one. So I'm gonna find the horizontal here, and because the position vector is going to be with the X and with the Y. So let's find with the X first, like the horizontal position. And here's going to be the vertical position. This is the first component of the position vector. The first component of the position vector. So the acceleration was sub x to the t equals 0. This is the acceleration with the y, because it's a gravity, so it's vertically with the y coordinate. With the x is going to be 0. So now v sub x to the t is going to be the integral of the acceleration sub x with the t dt, which is going to be v sub x with the t is going to be 0 plus c. Because the integral of 0, keep it 0, add the constant c. Now we have to go back to Cal 2. It's an x coordinate. So we already know that x is going to be equal v naught. This is from Cal 2, cosine theta. So keep this one in your mind. I'm going to use this one. Now, v with the start point here is going to be the t is 0. So v sub 0 is going to be v sub x to the 0 is going to be equal v naught cosine theta. So v naught cosine theta. The initial velocity is 800. So it's going to be 800 cosine. I'm counting this v naught cosine 45. That means v naught v sub x to the 0 is going to be equal, or let's say v naught 800 cosine, which is 1 over square root of 2. So this one is going to be 400 square root of 2. So v sub x, this is the v naught Yeah, well, this is this is the V naught. Don't confuse yourself. This is V naught. So now plug in the V naught here. Keep it with the X. So V sub X to the 0 is going to be equal 400 square root of T. Now I need to find the C, so I'm going to plug in V naught sub T here. That means V naught sub T is going to be 400 square root of 2T equal 0 plus C. So that means C is going to be equal 400 square root of 2. I have the value of C. I'm going to go back and write down the velocity vector with respect to the X. V sub X with respect to the T. V sub X with respect to the T is going to be just the C, which is 400 square root of T. So now I need to find the position vector with respect to the X. So the position vector with respect to the X with the T location at the T second is going to be the integral of 400 square root of T 2 dt, which is going to be 400 square root of 2t plus c r sub x with respect to the t. Now I have to keep going. At this point, at the t equal here, at the t equals 0, the x is 0. The x is 0. That means r of x at the 0 location is 0, because there is no range, there is no movement to the forward. So this is at the t equals 0, the position vector with respect to the x equals 0. So here's the initial. You have to figure out the initial point. I'm going to plug in this one here, and this one is going to be 0 equal 400 square root of t with respect to the t equals 0 plus c. That means c is going to be equal 0. So our position vector with respect to the x to the t is going to be just 400 square root of 2. This is now the first part of this function, because our position vector with all t, it's r sub x to the t and r sub y to the t. I found the first one, which is 400 square root of t. Now I need to find the second one. I didn't start now with the problem, because our problem is to find the height. I didn't find the height until now. I didn't find the range. I just need to find the position vector. So with the vertical position, so the vertical position, which is the second component here, so A, the acceleration sub y equal not 0. The acceleration, it means at this position, the initial, the acceleration for this one is going to be the gravity, which is 32. The gravity was going to be negative 32. That's really important. So now what I have to do, take the integral for both sides. That means v sub y with respect to the t is going to be the integral of negative 32 dt. That means v sub y with respect to the t equal negative 32 t plus c. Now I need to find this c so I can find the velocity with respect to the y. Also, there's an old rule from Carl II that says to find the y, it's V naught sine theta. I can use this one. So we're going to do exactly the same steps here, but with the y. So with the initial point, V naught is going to be with respect to the 0, V sub y to the 0 is going to be equal 800 sine 45. So V sub y to the 0 is going to be 800. The velocity, the initial velocity is going to be with respect to the y over 1 square of 2 also is going to be 400 square root of 2. Now I'm going to use this one to find the constant c. At the first point, here's the difference from the first one, which is also going to be the same thing. So the initial V naught is going to be V sub y to the 0 equal, plug in here, negative 32 times 0 plus c. That's mean V sub y to the t is going to be 400 square root of 2 equal c, because this is cancelled. So here is the value of c. That means V sub y with respect to the t is going to be equal negative 32 t plus 400 square root of 2. Now this is the velocity with respect to the t. I need to find the position vector with respect to the t, so I'm going to take the integral with respect r sub y with respect to the t is going to be equal the integral of negative 32t plus 400 square root of 2. So it's going to be, this is equal negative 16t squared, because negative 32t squared over 2 is going to be negative 16t squared plus 400, which is going to add t here, plus c. Now, here is the thing. Here is the first y, v sub y, or v sub, the position r sub y. So if you check the first position, is it 4 feet? On the one you got it here, it says 3 feet. I'm going to change it to 4 feet. 4 feet. Yeah, they used the 3 feet. I'm going to change it to the 4 feet. So now that's mean our initial position with respect to the y to the 0 when t equals 0 is 4. I'm going to use this one. That's mean r sub y to the 0 equal negative 16 t squared plus 400 square root of 2 times 0 plus c. This is cancel 0, and I didn't plug in 0 here. This is also 0. That's mean 4 is going to be equal c, because here is 4, this one equal 4, and here is c. So our position with sub y to the t is going to be equal negative 16 t squared plus 400 square root of 2 t plus 4. So here is the second component of the position vector, which is negative 16.
The position of x, shouldn't it have a t there?
Of the position of x. Yes, perfect. This is t here. Okay. Now this one is going to be t squared plus 400 square root of t square root of 2 t plus 4. So this is only the steps to find the position vector. The position vector, this one for the position with respect to the x, this one is going to be here, the position with respect to the y. That's what we need to find. So the maximum height, to find the maximum height, if you go back to Cal 2, is going to be the derivative when the derivative equals 0. To find the max height, the derivative of this component with respect is going to be equal 0. That's what we're going to start from the second part. Let's pull this one. If you want to take a screenshot, because we're going to keep going here. So now we have already the position vector. We're going to use this again, but now I need to find the time here, because that's the problem. I have the position vector, which is r over t equal, let's write down the position vector again, which is 400 square root of 2t, and the second one is negative 16t squared, and plus 400 square root of 2 t plus 4. I have the position vector, but I don't have the time. There's no time here to plug in to get the maximum height. So our goal now is to find the time. So I already know the derivative of the position vector with respect to the y equals 0. At the maximum height, the derivative of the position vector with respect to the y equals 0. So I have the position vector. Let's derive it with respect to the y. And so it's going to be r sub y. The derivative for r is going to be 400 just for the y. I'm not taking the x, just for this one. So it's going to be negative. Let's write down just without vector. It's going to be easier. So negative 32 t plus 400 square root of 2. Then what I'm going to do, this one equals 0. So 0 is going to be equal negative 32 t plus 400 square root of 2. That means t is going to be equal. I'm going to move this one to this side. So it's going to be 400 square root of 2 over 32. Simplify this one. 400 divided by 32 is going to be not. It's going to be decimal number. Simplify it by 8. Divide by 8. Divide by 16. So the time is going to be equal by 16, 25. Square root of 2 divided by 2. You can simplify this one, but it's going to be the root here. So just keep it like this. So this is our time. This is our time here on the maximum height. To find now the maximum height, what we're going to do, we're going to plug in this one, go back here, and this one is going to be the maximum height. That means r sub t with the y is going to be negative 16 t squared plus 400 square root of 2t plus 4. That means r sub y with the t, which is 25 square root of 2 over 2 equal negative 16. Plug in this one here, 25 square root of 2 over 2 squared plus 400 square root of 2 times t, which is 25 square root of 2 over 2 and plus 4. Let's check that with the calculator and how it's going to be. Can you see? Yes. So it's going to be negative 16 parentheses, the fraction, I'm going to use a fraction. So it's going to be 25 square root of 2 over 2. And this one, close it, squared. Plus, I hope it's not going to be a decimal number, but it's okay. If it's decimal, 400 square root of 2 and parentheses, I'm going to use the fraction again, 25 square root of 2 over 2 and close the parentheses and everything plus 4. So the maximum height is going to be 500. Oh, of course, it's going to be feet. So R sub y with respect to this t is going to be 5004. So this is the first part, which is the maximum height. The second part, we need to find the maximum range. The maximum range, here is the maximum range. So the maximum range is going to be, also we need to find the time. So at this point, you can see the graph. This is the maximum range. At this point, the position with respect to the y and the t is going to be 0, not the derivative. R sub y with respect to the t is going to be 0 at this position, because there is no t sub y. There is only R sub x, which is going to be the maximum range. So R sub x is going to be the maximum range because R sub y is going to be 0. I'm going to use this one because I have R sub y to find the t. So this is the second part. This is the maximum height. Now we need to find the maximum range. So the maximum range, R sub y to the t equals 0. Let's put this one a 9. So this is for the range. R sub y with the t equals 0. So I have R sub y here. That's mean negative 16 t squared plus 400 square root of 2t plus 4 is going to be 0. This is the quadratic equations. I can use a quadratic formula to find the t. So our time is going to be negative b. That's mean negative 400 square root of 2 plus or minus square root of 400 square root of 2 squared minus 4 times a, which is negative 16, times c, which is 4. And everything is divided by 2 times a, so 2 times negative 16. Negative 16, yes, here. Let's check that. I need to find this part here. I'm going to use the calculator. So t is going to be negative 400 square root of 2 plus or minus. How much is going to be here? Let's check it here. So the second square root of parentheses 400 square root of 2 square root of 2 and everything I have to get out of the root, close the parentheses, squared, minus 4 times negative 16, close the parentheses, times 4. How much is going to be here? This number, which is 565.911, and keep going. I'm going to use exactly the same thing over negative 32. That's mean the time is going to be equal. Now what I'm going to do, negative this number plus this one and divide by negative 32, because we have two solutions from here. 2 time, and check how we're going to choose the time. So it's going to be negative 400, square root, no, go back, negative 400 square root of 2. And this one, if I add it with this number, here is the result. This one divide by negative 32 is going to be, the first time is negative 0.0070. I think they asked to 4 decimal places. Four decimal places. This is the first one. I'm going to do the same thing with the second, because I have minus here also. So here's the same one, but I'm going to change the sign here to minus. Minus, and the result is going to be this number. Divide by 32, divide by negative 32 is going to be 35.36. 35.36, 240, 240.87. I can use the whole number by using at the calculator. Now here's the time. We can't choose the negative one because there's no negative time. So I'm going to use the positive one. So now I'm going to go back to R sub X is going to be the range. So the range R sub X to the time is going to be equal 400 square root of 2t. Now R sub X at the time 35.36, and the whole number is going to be 400 square root of 2 times 35.3624, and keep going, the whole number. That's mean it's going to be 400 square root of 2 times this number. You see the number? Here is the time. So it's going to be 3.99. They ask you to round to 3 decimal places, I think 9. So this is the maximum range. Talking about feet, it's really, yeah, maximum range is going to be feet, and the maximum height also is going to be feet. I know this is really long steps, but this is required. And the same thing we're going to do with the next example, but there is a little bit different on the next one. So for this one, a baseball hit 3 feet above the ground. So 3 feet here above the ground, and leaves a bit of angle. Here's the angle caught by outfielder, which is a 3. So here is also 3 feet. So and our theta is 45. So let's check how we're gonna solve this one. But they ask, what is the initial speed of the ball? But here, the ground, when it's above the ground at 300 feet, at home plate. That's mean the velocity here is 300. So I already know v sub x is 300, and the v sub y is 3, which is at this point. So now, at this point, the time equals 0, and r sub x is going to be 0. So let's start working on this one. We're going to do exactly the same thing, horizontal and vertical, to find the position vector, because our goal now to find above where, yes, here, what is the initial speed of the ball and how high does it raise? Initial speed and maximum height. So first of all, we're gonna find the initial speed. They give you a note here at the beginning. They said on example 7, initial velocity is not given. Use information for h and g and theta to full. So you see, here's all the solve the system. So that means we're gonna get a system of equations, and we're gonna solve this one. We're gonna get the velocity. Let's check that. Let's go back here. So I'm gonna start find the horizontal. The first component, the same thing, the acceleration sub x is going to be 0. That's mean. Check the integral of a sub x t t. So the velocity is going to be, with respect to the x, is going to be equal c. You have to do these steps. Like you're gonna plug in, when you check in the integral, is going to be 0 plus c, and v sub x with respect to the 0 is going to be equal c. No, this one is going to be equal 0. Oh, okay, equal 0 plus c. I'm gonna plug in this one, 0 equal 0 plus c. That means c is going to be equal 0. So v sub x to the t equal just c. You have to, this is the initial, we're gonna plug in here. Then the next step, the same thing, x equal v naught cosine theta. That's mean. Plug in this one here. So x is going to be v naught cosine 45, which is equal v naught square root of 2 over 2. This is the constant, which is the same thing, 1 over square root of 2. That means if you plug in this one with respect to the c here, this is the v naught. That means c is going to be equal v naught, which is, this is like a variable. We can say this is the initial velocity. Oh, that's where we're gonna find the initial velocity here with respect to the c. And this is the c equal v naught cosine, which is square root. Let's flip this one. That's square root of 2 over 2 v naught. So v sub x with respect to the t is going to be just this c, which is square root of 2 divided by 2 and v naught. To find the position with respect to the x is going to be the integral of v sub x to the t, which is going to be the integral for this one. So square root of 2 divided by 2 v naught t also plus c. This is r sub x with respect to the t. Then r sub x to 0, which is here, equals 0. That means everything here is going to be equal 0. So r sub x to the 0 is going to be equal square root of 2 divided by 2 v naught times 0 plus c. So c is going to be equal 0. Because this is 0. 0 is going to be equal. This is all 0 plus c. That means c is going to be equal 0. So r sub x to the t is going to be equal just square root of 2 over 2 v naught t. I forgot the v naught. Yeah, v naught t. Keep this one like this, and that's important thing with the next stage. Let's keep going to the vertical. Is going to be v sub y. I'm going to start with a sub y. The acceleration is going to be negative 32, because the same thing. So v sub y to the respect to the t is going to be the integral of a sub y dt, and v sub y to the t is going to be equal negative 32 t plus c. Let's go back here. Now with the initial, the same thing, we're going to use the formula to find the y. It's v naught sine theta at the initial point. That's mean y is going to be v naught sine 45, which is equal v naught, or let's write down square root of 2 and v naught. Plug in this one here at the point when t equals 0. That means v sub y to the t equals 0 equal square root of 2 over 2 v naught. So v sub y, let's find, because I already find the integral, I'm going to plug in now this one here. So v sub y to the 0 is going to be equal negative 32 and 0 plus c, v sub y to the 0, which is square root of 2 divided by 2 v naught is going to be equal. This is 0. This is the c. So this is our c again. Let's go back, plug in. So v sub y to the t is going to be equal negative 32t plus c, which is square root of 2 divided by 2. That's it, v naught. To find the position vector r sub y to the t is going to be the integral for negative 32t plus square root. This is not v2, this is v naught, divided by 2 v naught with respect to the dt. So r sub y to the t is going to be equal negative 16t squared plus square root of 2 divided by 2 v naught t plus c. The same thing. Now, to find the value of c at this point, the time equals 0. The height is, the v sub y is a 3. So r sub y to the 0 is going to be equal negative 16, 0 squared plus square root of 2 divided by 2 v naught with t is 0 plus c. This is equal to 3. equal, this is 0, this is 0. So here is the C. So R sub y to the t is going to be equal negative 16 t squared plus square root of 2 divided by 2 v naught t plus 3. 3, we have exactly the same thing, 3 feet above from both sides. So this is the first part. We just found the position vector. So R sub t is going to be, with the x, is just this one, v naught with the t, and with the y is going to be negative 16 t squared plus square root of 2 divided by 2 v naught t plus 3. This is our position vector. We have to keep going to find the speed. How are we going to find the initial speed? Initial velocity. At which point here, we already have the information for this one. We have the position vector, and we have 300. We have the height, we have the speed, we can find the time. And we're gonna get two equations, because the first thing I'm gonna plug in 300 with the x and the 3 with the y. So that's how we're gonna find two equations. Let's keep going. So my position vector is the position vector. That's what we got here. I'm just gonna type it here. The position vector is what I got, square root of 2 divided by 2 t v naught t. And I got negative 16 t squared plus square root of 2 divided by 2 v naught t, square root of 2 divided by 2 v naught t plus 3. Now, at this point, R sub x, the position vector at t is going to be equal, the same thing here, which is 300, and the height with the y is 3. So if you plug in 300 with the x and 3 with the y, we're going to get two equations. So I'm going to say square root of 2 divided by 2 v naught t, this one equal 300. The first one. The second one, I'm going to say negative 16 t squared v naught t plus 3, no, v naught plus square root of 2 divided by 2 v naught t plus 3 equal 3. This is the second one. Now I'm going to solve this one. So I'm going to use by substitution. T is going to be equal 300 divided by square root of 2 divided by 2 v naught, which is equal, flip this one, so it's going to be 600 divided by square root of 2 v naught. So this is the t from this one. I'm going to plug in here. So we're going to solve it to find the initial velocity. So plug in this one here on the second one. So it's going to be negative 16. And 600 divided by square root of 2 v naught squared plus square root of 2 divided by 2 v naught with the time 600 over square root of 2 v naught. Here's the time, a plus 3 equal to 3. Then this one with this one, 0. Cancel v naught with the v naught, square root with square root. I'm going to keep this one. So here is going to be negative 16. Square root of 2 squared is going to be 2. That means I can get this one out as a 2. And here is V naught squared. I'm going to keep this one 600 squared here. The plus 600 divided by 2 is going to be 300 equal 0. Negative 16 divided by 2 going to be negative 8. I'm going to keep this number here. It's up to you the way how you're going to simplify it. It's fine. Over V naught squared plus 300 equals 0. Then I'm going to divide, multiply both sides by V naught squared. Yes, by V naught squared. So it's going to be negative 8, 600 squared plus 300 V naught squared equals 0. That means V naught squared is going to be this number divided by this one. So it's going to be negative 8, 600 squared divided by negative 300. That means V naught squared is going to be 9,600, which is mean, take the square root for both sides. V naught is going to be the square root of 9,600. So the square root of 9,600 is going to be 4 times 1,600. 1,600 times 4. So V naught is going to be equal 40 times, not 4, times 6. So it's going to be 40 square root of 6. If you're going to write down as a decimal number, it's fine. But it's positive, negative, positive, negative, positive, negative. There is no velocity with negative, so we're just going to take the positive one. So the initial velocity, you're going to plug in here a decimal number, which is mean 600 or 40 times the square root of 6. So it's going to be 97. This one, the same thing. 97.9795. 9795 or 96. Because you're gonna round. But I'm going to use this one because it's like the exact solution, or if you're using the calculator, it's fine. Our goal, the next one, to find the maximum height. The maximum height is going to be, we're gonna depends about this one, V sub y. So as a position factor, R sub t is going to be, I have the velocity, which is V naught. I'm going to just plug in the V naught here to get the maximum height. So it's going to be, find the position vector, plug in the V naught. That means square root of 2 divided by 2. V naught is 40. Square root of 2 and t. And here is negative 16 t squared. And we plug in this one here. T squared. Let's add down the position vector. Yes, t squared plus square root of 2 divided by 2 V naught, which is 40 square root of 2. And here is the t plus 3. That means our position vector with respect to the t is going to be 40 divided by 2 is going to be 20. The 20, oh, here is the wrong thing. This is not 2, it's 6. V naught is 40 square root of 6. So it's going to be square root of 12, which is 4, and 20. So it's going to stay 40 square root of 3. And here is the t. On this one, 16, still the same thing, a plus 40, and this is 6 with the 2 is 12, square root of 12, 4 times 3, that means 2 out, cancel with this 2, so it's going to be still 40 square root of 3. And here is the t plus 3. So this is our position vector. To find the height, the maximum height, now I need to find the time. So I'm going to take this one and equal it to the 0, because the derivative of the position vector with respect to the y to the t is equal 0. That means the derivative for this part is going to be negative 32 t plus 40 square root of 3 equals 0. So from here, the time is going to be equal negative 40 over 32. So 40 square root over 3 divide by negative. If you move this one, so it's going to be 32. So the time is going to be equal 5 square root of 3 divided by 4. By 5, by 8, by 8, going to be 5 over 4. This is our time. Now, so just plug in the time here to find the maximum height. That means the position vector with respect to the y to the time is going to be equal negative 16 t squared plus 40 square root of 3 plus 3. Position vector with respect to the time, which is 5 square root of 3 divided by 4 is going to be equal negative 16 5 square 5 square root of 3 divided by 4 squared plus 40 square root of 3. I forgot the time here. So 5 square root of 3 divided by 4 plus 3. That means this one is going to be equal. Let's check that faster. It's going to be negative 16 parentheses. Let's use the fraction mode, which is going to be 5. The second one, square root of, here we go. Use the fraction mode, is going to be 5 square root of 3 and divide by 4. That's it. Squared. Go down plus 40. The second square root of 3 and parentheses. Make sure the parentheses outside the root. This one, the fraction, also 5 square root of 3 divide by 4. Close the parentheses, and everything is a plus 3. The result is going to be 7, 8. This is the maximum height. It's exactly like the same process with the first example, but the difference here, they ask you to find the initial velocity, and then they're gonna ask you to find, we need to find the position vector, and after that we're going to find the maximum height. That's it.